This video covers question 1, part A of the 2021 AP Calculus AB free response section, calculator required portion of the test. I cover each of these little A, B, C, and D's in their own individual videos because they're kind of their own individual little topics. So this video only covers question 1A. If you want to see the other ones, you can find my videos on YouTube, on my website, wherever you want to find them. So looking at part A here, this is a classic little question that they like to put in front of us. They want us to use this table up above to estimate a derivative value. And so we're not looking to get the exact derivative value because we don't have an equation. And so really what they want us to do is use our average rate of change to approximate the derivative value, which is the instantaneous rate of change. So average rate of change is just fancy math talk for slope, as we've always known it, which is y2 minus y1 over x2 minus x1. So what you do is you go up to your table and you say, okay, well, where does this value live? So this is our x value. These are our x's on top and essentially our y's on bottom. So this is an r value of 2.25. And you'd look at your table and you would say, okay, well, 2.25 is going to live in between 2 and 2.5. So those are going to be the points that we want to use to run just a standard slope setup. So my first point I would use would be 2, 6. And then the second point I would use would be 2.5 and 10. And so there's x1, y1, x2, y2. And so we just, to approximate this now, we're just going to go ahead and pop those into our standard slope formula. So y2, which is 10, minus y1, which is 6, over x2, which is 2.5, minus x1, which is 2. And so out of there, we get 10 minus 6 on top is 4, and then 2.5 minus 2 on bottom is 0.5, and then 4 divided by 0.5, that's going to be 8. And now what we have to do in the end of this all is we need to come up with our correct units for that answer, and then they want us to interpret the meaning of the answer in terms of this problem. So whenever I need to do the units on a problem, I always kind of go back to this idea of the standard derivative notation, which is dy dx. That's always saying the change in my y units over the change in my x units. And then I just go and I kind of turn that same notation into the language of this problem. So our x units on this are the r values, and our y units are going to be these f of r values. So what we'd really be looking at is df, because that's our y units, over dr, that's our x units. So df is in milligrams per square centimeter, so milligrams per centimeter squared. And then from there, you would come through and say, okay, well, that's all over the units of our R, which is in centimeters. And then I would kind of clean this thing up a little bit. So those are our units. So this would be milligrams per centimeter squared per centimeter. And that's kind of some weird units, but that's how you got to kind of break these things down so that they, when they don't make sense, you still can find an answer. So this is 8, and then this would be milligrams per centimeter squared per centimeter. Those are the units right there. So that gets us the correct units on our answer. Now let's kind of put together the interpretation portion. What does this mean in the end? So we were just approximating f prime of 2.25, and we got out our answer of 8 and then milligrams per centimeter squared per centimeter. So just start taking it down a chunk at a time. And so what it's saying is when R is 2.25, so go back up and you say, okay, well, what does R mean? R is the distance R in centimeters from the center of the dish. So you'd say when you are 2.25 centimeters away from the center of the dish. So you're describing basically your x units to start with. The next thing they want you to then usually say is whether this thing is going to be increasing or decreasing. So if we have a positive derivative, we know that it's increasing. If that was a negative number we'd gotten out, then that would tell us that it's decreasing. So then we would say that we are the So the F, the F of R, the density of the population, the density of the bacteria population, that's what the F of R portion is. The density, and again, so now you're describing the Y portion of it. So then the density of the bacteria population is increasing. And then you put in this language, you would just say at a rate of. And now you would put in your rate portion of this. And so at a rate of 8 milligrams per centimeter squared per centimeter. And again, like that's where you got to have a method for kind of putting together your units here, because sometimes it's nice and easy. Sometimes they're talking meters per second, miles per hour, something you're comfortable with. In a problem like this, they were talking to us about milligrams per centimeter squared per centimeter. And the only way I would ever be able to get to that is by starting with something that I'm familiar with, turning it into the language of the problem, and then just using those units the same way. It's Y units over your X units. And when you go to interpret it, it's, you start off and you always want to say, when my X is doing this, the Y value is, and then you always want to be talking to them about increasing or decreasing. And then this is your rate. Then your derivative piece would be right here. And that's really how the language breaks down every single time when you're going through interpreting the meaning of a problem like this. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.